ES2-2-2 aluminum wire is adequate for the application, assuming certain conditions are met. Firstly, circuit protection is essential. A 100 amp circuit breaker should be installed in the panel to protect the circuit. Secondly, voltage drop must be considered. The voltage drop over the 120-foot run, considering the 100 amp load, should be within acceptable limits. A voltage drop calculator can be used to verify this. According to the National Electrical Code, 2-2 aluminum wire is rated for 100 amps in this specific application. While the maximum load is expected to be less than 100 amps, it is recommended to size the wire for the maximum potential load. This ensures it can handle future additions or unexpected changes in usage. The voltage drop over a 120-foot run using 2-2 aluminum wire will be approximately 2.5 volts. This is within the acceptable range for most electrical equipment. Aluminum wire is more affordable than copper wire. However, it is also more prone to oxidation and must be properly terminated to prevent loose connections. The wire should be installed in conduit for protection from damage and to ensure proper heat dissipation. A proper grounding system must be in place to protect against electrical shock. It is recommended to have the electrical installation inspected by a qualified electrician to ensure it meets all applicable codes and safety standards. Overall, 2-2 aluminum wire is a suitable choice for this application, provided that the appropriate circuit protection, voltage drop considerations, and installation practices are followed. Let's delve into each of these aspects in more detail. Firstly, let's discuss circuit protection. A circuit breaker is a crucial safety device that protects the electrical circuit from overcurrents which can be caused by short circuits or overloads. The 100 amp circuit breaker installed in the panel will trip and interrupt the flow of electricity if the current exceeds 100 amps, preventing damage to the wiring and equipment and reducing the risk of fire. Secondly, voltage drop is an important factor to consider in any electrical installation, especially over longer distances. Voltage drop refers to the decrease in voltage that occurs as electricity flows through a wire. Excessive voltage drop can cause equipment to malfunction, operate inefficiently, or even be damaged. The acceptable voltage drop typically ranges from 3% to 5%. For a 240-volt circuit, a 3% voltage drop would be 7.2 volts, and a 5% voltage drop would be 12 volts. In this case, the voltage drop of 2.5 volts is well within the acceptable range. To calculate voltage drop, you can use the voltage drop calculator, which takes into account the wire size, length of the run, current, and voltage. Several online calculators are available. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations in the United States. The NEC specifies the ampacity, or current carrying capacity, of different wire sizes and types. According to the NEC, 2-2 aluminum wire is rated for 100 amps in this application, assuming it is installed in accordance with the NEC guidelines. It's essential to consult the latest edition of the NEC for specific requirements and regulations. While the maximum load is expected to be less than 100 amps, it is prudent to size the wire for the maximum potential load. This provides a safety margin and allows for future expansion or changes in electrical usage. For example, if the son decides to add more tools or equipment to the barn in the future, the existing wiring will be able to handle the increased load without needing to be replaced. Aluminum wire is a popular choice for electrical wiring due to its lower cost compared to copper wire. However, aluminum wire has some unique properties that must be taken into account during installation. One important consideration is that aluminum wire is more prone to oxidation than copper wire. When aluminum oxidizes, it forms a non-conductive layer on the surface of the wire, which can increase resistance and lead to overheating. To prevent oxidation, aluminum wire must be properly terminated using connectors that are specifically designed for aluminum wire. These connectors are typically coated with an antioxidant compound that prevents oxidation and ensures a good electrical connection. It is also important to tighten the connections to the proper torque specification to prevent loose connections, which can also lead to overheating. The wire should be installed in conduit for physical protection and to ensure proper heat dissipation. Conduit is a rigid or flexible tube that protects the wires from damage caused by impacts, abrasion, and moisture. Conduit also helps to dissipate heat generated by the wires, which can prevent overheating and extend the lifespan of the wiring. Different types of conduit are available, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit. The choice of conduit depends on the specific application and local electrical codes. A proper grounding system is essential for electrical safety. A grounding system provides a path for fault current to flow back to the source, which causes the circuit breaker to trip and interrupt the flow of electricity. This protects against electrical shock and reduces the risk of fire. The grounding system typically consists of a grounding electrode, such as a ground rod or metal water pipe, that is connected to the electrical panel with a grounding wire. It is crucial to follow the NEC guidelines for grounding to ensure a safe and effective grounding system. Finally, it is highly recommended to have the electrical installation inspected by a qualified electrician. A qualified electrician has the knowledge, skills, and experience to ensure that the installation meets all applicable codes and safety standards. An inspection can identify potential hazards and ensure that the wiring is properly installed and grounded. This can provide peace of mind and help to prevent electrical problems in the future. In summary, using 2-2 steel aluminum wire for this application is generally adequate, but remember that these are essential. Adequate circuit protection with a 100 amp breaker. Ensuring the voltage drop is within acceptable limits, ideally below 3%. Adherence to the National Electrical Code guidelines for wire ampacity. Properly terminating the aluminum wire with suitable connectors and antioxidant compounds. Installing the wire and conduit for physical protection and heat dissipation. Implementing a proper grounding system to protect against electrical shock. And finally, having the installation inspected by a qualified electrician. By following these guidelines, it can be ensured that the electrical installation is safe, reliable, and meets all applicable codes. Keep in mind that electrical work can be dangerous, and it is always best to consult with a qualified electrician if there are any doubts or concerns. A licensed electrician can assess the specific needs of the application and provide expert advice on the best wiring methods and materials to use. They can also perform the installation safely and correctly, ensuring that the electrical system is up to code and meets all safety requirements. For the welder that may be used, consider its duty cycle. The duty cycle of a welder is the percentage of time within a 10-minute period that it can operate at its maximum rated output without overheating. For example, a welder with a 60% duty cycle can operate at its maximum rated output for 6 minutes out of every 10 minutes. If the welder is operated beyond its duty cycle, it may overheat and be damaged. The duty cycle of a welder is typically specified by the manufacturer and should be considered when selecting a welder for a particular application. If the welder will be used for long periods of time, it is important to choose a welder with a high duty cycle. Also consider the inrush current. Inrush current is the instantaneous peak current drawn by an electrical device when it is first turned on. It is often significantly higher than the device's normal operating current. This is especially true for devices with motors or transformers, such as welders. The inrush current can cause voltage dips and can potentially trip circuit breakers or fuses if the electrical system is not properly sized to handle it. When sizing the electrical system for a welder, it is important to consider the inrush current in addition to the welder's normal operating current. The inrush current can be estimated based on the welder's specifications, but it is always best to consult with a qualified electrician to ensure that the electrical system is properly sized. Remember that local electrical codes may have specific requirements for welder circuits. These requirements may specify the minimum wire size, circuit breaker size, and grounding requirements. It is important to comply with all applicable codes to ensure a safe and legal installation. Also keep in mind that the information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work.